If people colonize everything, which I'm hoping will happen, and I expect to happen, then most things that happen in space-time are caused by people. Now, our educational system is still very archaic, and it's based on what Popper called the bucket theory of the mind, which is that the mind is a kind of bucket for knowledge, and that education or upbringing consists of pouring some of this knowledge from the earlier generation into the next generation. But that's not possible. By suppressing disobedience, you're suppressing creativity always. I mean, why are there exams in which the students don't get 10 out of 10? I mean, what is the point? Oh my God, a nice breeze. We never get that.
David, thanks so much for joining me.
It's a pleasure. So, where are we going?
You have quite a tragic view of human history, and can you explain that view and talk about why you see human history as a long period of complete failure?
I think it's unanswerable that that's what it was. We know that our species, like anatomically, originated about 300,000 years ago. Maybe there were some tweaks, and it's only 200,000, but around about that time. And throughout that time, we know that our ancestors were capable of creative thought because they created things like campfires. And making a campfire involves putting together several things that you have to plan in advance, and you have to do things which you do in order to do the next thing, in order to do the next thing. Like you have to make a space for the fire so that the kindling won't be blown away. Then you have to get the kindling, and what's it called? I'm not a campfire person, but there's kindling, and then there's a second thing. Well,
okay. No, the spark?
No, the spark is a different thing. Yeah, you have to know how to make a spark as well. Or you could wait till the next lightning strike on a tree and get a branch, but that may be how they first realized that there was such a thing as fire. But if you want to make fire intentionally and use it, you can't just make fire. It's got to be burning there for a long time. Anyway, they did that, and it spread around the world. And then you can tell, if paleontologists find the remains of a campsite from a couple of 100,000 years ago, they can't date it from the style of the stone tools and so on to better than a few thousand years, if that. So that means that on a timescale of 2,000 years, nothing noticeable was invented. We can tell from the fact that there was a campfire that there were sophisticated people there, as sophisticated as us. Now that's already quite a tragic fact, because their lives were extremely unpleasant. And also their population increased very slowly. So why doesn't the population increase fast? Well, famine, climate, predators, exhaustion of the environment or other people. So their lives were very grim, so unimaginably grim by our standards. And then when civilization began, which people kind of date to settlements, villages, and so on, the rate of progress increased slightly. So when you see some pottery, the experts can say, "Oh yeah, that's late Bronze Age" or something like that. But that's still a very low resolution. Now if you see an iPhone, you can say, well, not late Bronze Age, that's late 2022. You know, so things are changing faster and faster, and all the things that change are things that people at least think is better than the previous version. So people don't work to get the next version usually if they have the previous version. So the change, the important change, sort of historically, I think, is the moment when a typical person could notice that lifestyles were changing during their lifetime. So when you know that you're living differently from your parents and they were living differently from their grandparents, that is a completely novel thing to happen to the human species. For most of those hundreds of thousands of years, that didn't happen. People didn't even have a conception of that something could improve. You know, except occasionally when somebody invented a better technique for making the campfire or something. You know, realized that you have to stack the wood. You know, it's better if you stack the wood one way than another. But that was very, very rare. If that had happened on a noticeable timescale, then there would have been exponential improvement, and we would have had civilization within a few generations. And so you say I have a grim view of the past. Well, it depends how you look at it. If you look at it backwards in time, it gets grimmer and grimmer. If you look at it forwards in time, it's first incredibly frustrating for hundreds of thousands of years, and then it's the opposite of grim. It's hopeful, and that's where we are now.
Why do you think that changed with the Enlightenment?
It is a puzzle that I thought about a lot. How it is possible that creatures, apes, humans, with our cognitive capacity. I couldn't invent a campfire if I didn't know in advance. You know, I'm not that kind of person. It takes some kind of genius to do that. So those people were intellectually our equals, and yet made no progress. So the question is, if they were intellectually our equals, that means that faculty of mind must have evolved. You know, there's nothing else that can create that kind of knowledge apart from biological evolution. So they must have evolved to have that capacity. And then from our perspective, they simply didn't use it. Now, I think that's impossible, because it couldn't have evolved unless they were using it during the whole time that it evolved. Because there must have been, you know, a selective advantage for the people that had slightly more of whatever it was, to build up from whatever it was to what we have now and what they had hundreds of thousands of years ago. So what were they using it for? And I think it's I can't think of any other possible way this could have happened than that they used it for replicating memes. So memes are bits of culture, patterns of behavior, like making a campfire in a particular way, or speaking in a particular language. By the way, language also evolved and must have been used while it was evolving. People sometimes forget that. It must have been used before it was at our level. They must have had some way of storing that cultural information. But cultural information, unlike genetic information, cannot be just mechanically transferred. In our cells, in every cell, there is all the genetic information that we have, and to copy that into the offspring is an automatic process. It doesn't require any kind of information processing other than copying. But memes, information, culture is not like that. There's no way of copying information from one mind to another. And here is where Popper's epistemology comes in, because Popper realized that there is no such thing as copying by instruction either. Our educational system is still very archaic, and it's based on what Popper called the bucket theory of the mind, which is that the mind is a kind of bucket for knowledge, and that education or upbringing consists of pouring some of this knowledge from the earlier generation into the next generation. But that's not possible. It can only come by conjecture and criticism, according to Popper, and he's, I think, obviously right once you get it. It comes from within. It comes from conjecture from the recipient, not from the intentions of the transmitter of the cultural information. So that means, but you can't translate a piece of culture faithfully just by copying it. So if I see, let's say, a tennis player, playing, I can try and copy him in an ape-like way, and I'll be rubbish at playing. And so how is it that the coach can then get me to, well, it's not by saying, well, hit it just before the top of the bounce or whatever. It's by me guessing what the coach means, and the coach guessing what I'm not getting. And so between us, we can arrange for me to learn how to play tennis well, and that will only work if I want to play tennis well. So I might want something else. And this creative capacity must have been used for transmitting memes, or for receiving memes more precisely, and it wasn't used for anything else. Why wasn't it used for anything else? Because in the theory of evolution, we know that things only ever evolved towards greater fidelity. Some people think that there's an optimum level of error correction in the DNA mechanism, because if you correct too much, it won't evolve at all, and if you correct too little, then you might be killed, and so on. But that's not true. Biological evolution only ever evolves in the direction of greater fidelity, and the fact that there is any mutation left is not evolution's fault. It's just how the physics of the thing works out.
Can you explain the term fallibilism, and how does it differ from relativism and dogmatism?
Chalk and cheese, or polar opposites, really. So fallibilism is the idea that we're not infallible. Now, everybody knows that they're not infallible about some things. Everybody knows that they don't know in detail how a TV works, or how a crop of corn is sown, and so on. Everybody knows that they're ignorant and have misconceptions about some things, but they think there are some things you can be absolutely sure of. Religious people think they can be some religious people think they can be absolutely sure of their religion. Some people have transferred that idea to science, which is sometimes lampooned as science with a capital S, science, which is a mistake, because science is a process of discovery, of critical examination of existing ideas and finding problems within them and solving them with new theories. So our best theories at one time are not the same as our best theories at a later time. So it's simply wrong to think of the world as scientists being infallible. then some people think, oh well, at least 2 plus 2 is 4. You know, we can't be wrong about that. Well, it depends what you mean by that. Suppose you're a primary school pupil and you get an exam and it says 2 plus 2 equals, and you write there 2 plus 2. 2 plus 2 equals 2 plus 2. That's going to be wrong. It's true, but it's the wrong answer to the question. So it's not entirely true that 2 plus 2 is 4. If you had said 3 plus 1, or it depends on the context. You might have just learned that 2 plus 2 is 2 times 2, which is an extremely interesting fact. But it's also true and interesting, but it's still not the answer. So what I'm trying to say, rather laboriously, is that language is inherently imprecise and context dependent. And when we say that we know for sure that something is the case, we can never, we're trying to grasp an abstract thing, something about the integers, something about numbers, something about the operation of addition. So somebody might say, no, you can still be certain about 2 plus 2 is 4 because you're just expressing it in a certain language. And if you say 2 plus 2 is 3 plus 1, that is true, but it's not the right answer expressed in the language of the culture in which you're in, and that's an objective fact. But you know, if you were an ancient Roman and you wrote that 4 is 3 plus 1, 3 strokes, and then 1 stroke, it would be right. Or 2 strokes plus 2 strokes, it would still be right. So, and then you might say, wait a minute, 4 is 1v. No, it isn't. The ancient Romans had 1, 1, 1, 1 for 4. The 1v is a later invention. And there will have been a time when both things were used and when it was ambiguous. And both things are used today even. If you look at a clock face that's got Roman numerals, they still, for some reason, use 1, 1, 1, 1 rather than 1v. The way I like to think of this is that there are absolute truths in the abstract world which we approximate with language. We approximate this by saying certain utterances. 2 plus 2 is 4, and so on. And those utterances are subject to error. The Americans had a Mars probe a while ago, and it crashed because some of the engineers were using metric units and some were using imperial units. So you can't be absolutely certain of anything. This has implications not just for mathematics and for speaking and so on. It has very important implications for things like politics, because if some political idea, if you thought you knew some political idea with certainty, then that would change the morality of politics. It would make it immoral for somebody to try and thwart you, because you are right, and you are infallibly right. And this idea has indeed killed people in many cultures. But then people say, well, if nothing is certain, how can we ever know anything? And then you have to realize that all our knowledge is conjectural. All our all the information, the knowledge, the words and sentences in science are all they all have the form of either conjectures, where you're saying, maybe it's so-and-so. Even if you don't say maybe, you mean maybe. Or criticism, conjectures or criticism. So that can't be right because so-and-so. Or can that be right because this other thing, and so on. And that's how science progresses. And although we can never know in the sense of certainty that we are right about something, we can know that we don't have any further criticisms of it. So in that case, we use it. So I think that the ground isn't going to open up and swallow us, just because there's been a bit of rain recently. And I don't know that for sure. I mean, there are people who've been swallowed up in sinkholes when they were least expecting it. But the idea that there is a sinkhole here which is going to swallow us up fails the most elementary criticism. So I can reject that. It's rational to reject it. And being rational doesn't mean that you're guaranteed to be right because of fallibilism again. But it is the way to improve our knowledge. It's the way to correct errors. So if we have an idea that is false, and we then find a flaw, and we find a better idea, we are better off objectively. We just don't know for sure that that is so.
Can you give an example or two of how cultural relativism has severely impeded progress, or at least destroyed significant human capital?
Right, well, where do I begin? So at the moment there's a wave of cultural relativism, which is part of what they call woke and that kind of thing, which demonizes claiming that one culture is better than another. Now, this means, so among other things, this means that there's no such thing as improvement, because if we are to improve our existing culture, and by culture I mean everything we know or think we know, if we want to improve that, we're hoping that we will reach a state which is better than the previous state. So the state, like next year, will be better than the state now. So the next year we could say our culture before was worse than our culture now. And cultural relativism, and the same holds for moral relativism, would forbid saying that. And the same thing is true about different cultures, not the same culture at different times, but different cultures at the same time. So if our culture improved, if I thought of improvement to our culture now, and I hadn't told anybody yet, then our culture would be better here at this spot where I am, and less good elsewhere. And if this spread to the whole country, then the whole country's culture would be, assuming that the whole culture of the world was homogeneous and equal, then as soon as there was any improvement, it would happen somewhere, and that somewhere would have a better culture. And again, if we're forbidden from saying that or thinking it, then we're forbidden from making that improvement as well, because the converse of saying that it won't be better is saying that you're not only are you wrong factually that this would be a better piece of culture, but you're wrong morally, because you're trying to change the culture which is already the best it could be. Now, I suppose that you might say that sounds a bit theoretical, but this is happening in real life all the time. I'm thinking of, for example, Richard Dawkins got very irate a couple of years ago when he went to New Zealand, and New Zealand was about to implement indigenous ways of knowing into the school curriculum. And this is indigenous ways of knowing physics, for example, among other things. So Richard Dawkins was saying, no, there's only one way of knowing physics. He didn't say, and that way is fallible, which I think might have helped. But he insisted that these indigenous ways of knowing are worse than the Western ways of knowing, which aren't Western in the sense of being attached to a particular set of people. It's just a geographical statement about where the knowledge was where that way of knowing was first created. Just like we call what languages are known by their origin. Well, Latin, for instance. Latin was begun in the central regions of Italy, in the Latin region. But now when we speak of Latin culture today, we don't associate it with that region at all. Same with Western culture, Western ways of knowing, Western science is just a tag of where it originated. But it's a way of specifying something that is objectively better than indigenous ways of knowing.
And what is objectively better about the Western civilization?
Well, it can make progress, so it can make objective progress is the one thing that's objectively better. All forms of knowledge began with indigenous ways of knowing. They began with ideas that were located in a tribe and which were conjectured by people in that tribe to solve certain problems. And they were better than nothing, usually. Sometimes they were worse than nothing, but usually they were better than nothing. But they were terrible by our standards. And so indigenous ways of medicine, indigenous ways of physics are terrible for use today, to solve problems today.
You have a great TED Talk titled "Chemical Scum That Dream of Distant Quasars," and you refer to Hawking's quote of, "The human race is just a chemical scum on a moderate-sized planet orbiting around a very average star in the outer suburb of one among 100 billion galaxies." But you take issue with this quote, and can you explain what makes humans and people so special, and what's wrong with this chemical view, chemical scum view of humans?
As I said, there is, first of all, knowledge has a powerful effect on the physical world. So if we look around where we are now, we can see trees, but they're not the same breed of trees that were, the species of trees that were here before people were here. The trees are here because people wanted them here. And then there are buildings, and the buildings are here because people wanted them here, and they could build them because knowledge of how to build them and how to build them sufficiently cheaply had spread by that time. And in the buildings there's things like sanitation and running water, which reduce the diseases that would have been here before there were any houses. And in fact, it's a warm day today, but it's for certain that if I tried to live just in this garden before the advent of civilization, I would have died within a day. The climate in England is not suitable all year round for humans, so I would have needed to invent something like a fur coat and a way of finding clean water and a way of finding food, and the food around here is only in the natural state. Here, the food around here is only suitable for sustaining a few thousand people in the whole country. With a few million people in the whole country like now, we would all have starved. So knowledge affects the physical world, not just us, but if you look from space, you can see the effects of humans. And knowledge, there's only one way of creating knowledge, so in the Popperian way of conjecture and criticism. That's where all that knowledge that I've spoken of was created in that way. And for every true idea, there were many false ideas, many false starts, many blind alleys, many things that made matters worse. But because of the method of conjecture and criticism, which was only really installed properly something like 300 years ago, we had rapid progress that made all these things around us now. Before that, between the dawn of civilization and the Enlightenment, or whatever you would call it, scientific revolution, several hundred years ago, there was very, very slow progress. The ancient ways of thinking where creativity was used to suppress change rather than to cause change were still ubiquitous. So people who tried to do things differently were stopped. And if they did manage to do something differently, they were prevented from passing the idea on. And if they were wrong, they were not enabled to improve upon their error. So errors got entrenched, and things were bad, and then in the following generations they were just as bad. And on the whole, they weren't improved. So in the last couple of thousand years, they were improved on a timescale of several generations. But even then, like if you look at the design of a cathedral 1,000 years ago, you can't date it, like the experts can date it maybe to within a few hundred years or something like that, but you can't say, well, that was a fashion that happened in 1193 and then died out in 1194. There was no such thing. Fashions weren't allowed. All people's creativity was devoted to meeting existing criteria faithfully. So the progress didn't happen.
I want to read a quote from you that you actually shared with me. It's from Antonio Stoppani, from his geology textbook. And he said, "I do not hesitate to proclaim this the Anthropocene era. The creation of man is the introduction of a new form of being into nature, a force previously absent from the world. This new element, more than any that has previously existed anywhere, not only relates the non-living world to the living, as had already happened, but, in a new and mysterious way, unifies physical principles with intellectual and moral ones. It is a force which, in its power and universality, is not inferior to any of the other great forces of nature."
Well, I totally agree with that, and I was stunned when I found that quote from Stoppani, because that's late 19th century. I forget the exact date. When the kind of examples that one would give today to talk about rapid change and about the power of human creativity to change the universe, the examples would have been very weak compared with today. And yet he saw it already as a geologist, because he could see, I don't know, I'm not a geologist, but I assume that he could have noticed this fact that I've been going on about now, that a geologist can dig in the ground and find things that can be dated to within a year now. But if you go back a bit further, they can't be dated to within 100 years, and then further back they can't be dated to within tens of thousands of years. So something dramatic has happened to geology. And he had the genius to recognize that this isn't just geology. The power of creativity to create ideas, and then the power of those ideas to change the physical world, is unlimited. And it is indeed to be compared with the power of gravity or the power of electromagnetism and so on. That, we haven't done things like change the orbit of the Earth. One day we will, perhaps, when the sun goes red giant. But we've already changed the orbit of an asteroid, and that was unthinkable in Stoppani's day. That flight hadn't been invented yet, but he saw what was coming, and he wrote that apparently in the last days of his life. So quite interesting that he found that and thought it worth stressing in his geology book. By the way, it's a massive book, three very thick volumes of hundreds of pages. I haven't read the rest of it because I don't even know if it's out of date now.
Just found one good quote.
Yeah, he invented the term Anthropocene to mean that, and now I've forgotten there's some controversy about the terminology. The Anthropocene era, is it the Anthropocene era or something?
I think Anthropocene has the word era in it, so it means like the age of humans itself.
Yeah.
So,
So I don't know.
Yeah. Anyway,
I think he was right, and the prevailing usage today is wrong.
But religions, a lot of religions seem to get that and understand that humans are special, and they placed humans at the center of things.
I think religions that I know of usually place humans at the center morally. That is, humans have an intrinsic value and maybe most other things don't, and humans also should do things. They have should that applies to them, whereas other things don't. But I haven't seen a religion, except maybe IAC or something like that, that thinks of humans in terms of what they will do to the physical world in the future, and what they are doing and what they have done. That humans are special in that sense, in that they are the agents in the in the universe, not just the patients. And I once said, and I think this sums it up, that I'm hoping that if this exponential growth goes on to humans colonize the solar system, and then the galaxy, and then the universe, and so on, if that all continues, and if we meet other people, then we will do it together. If people colonize everything, which I'm hoping will happen, and I expect to happen, then most things that happen in space-time are caused by people. If we look around space-time today, we don't see that. You know, we only see it on the surface of the Earth, which has indeed been revolutionized by the presence of people. People will illustrate this by showing aerial views of cities, and they're very different from any cliffs.
North Korea and South Korea.
Yeah, that too. Yeah, well, so they both have people, but they have people whose creativity is devoted to keeping things the same, and people whose creativity is devoted to improving things. And that's the difference that matters to me. So in the future, there's a lot more future than past in the universe. So most things that happen in space-time will happen because people cause it to happen.
What makes us different from the other great forces of nature, like evolution and gravity?
So the other great forces of nature are dumb. So they don't improve. They have their power, and they exert their power, and the power that they exert has been the same ever since almost the beginning of the universe. So right near the beginning of the universe, there were stars, there were supernovas, there were black holes, there were gravitational waves, and so on. I could go on a list of things, and all of them still exist today, and they are slightly different today. For example, the proportion of the different elements in the stars is different today than it was near the beginning of the universe. I say near the beginning, I'm talking about like 300 million years, but that's not much on the scale of the universe. After like the first 300 million years, nothing happened. Nothing new happened. The world just went on doing, the universe just went on doing what it was doing at the beginning, and you know, you'd see the same kind of, there was a sort of certain menagerie of types of stars and types of planets and so on, and it was the same then that it is now, as I say, with slight changes about chemical elements. And in the future, it'll be completely different. Once humans are expanding, then there'll be a bubble where there's novelty all the time. There are problems of novelty even now that we've got to manage. And the further out we go, the more of us there'll be, the more creativity there'll be, and the more the faster novelty will be created, and the faster progress will happen. Then we'll get to the place where because of light travel time, the world will cease to be homogeneous, because different parts of civilization which has spread, across the galaxy, will take tens of thousands of years to learn of each other's progress and to pick and choose which bits of it they want, and so on. So the universe, which has been homogeneous on a large scale ever since the Big Bang, will start being inhomogeneous, and ever more inhomogeneous. And there'll be a constant cross-fertilization on every time scale. There'll be a cross-fertilization on time scale of a year, when things are a light year apart, and 10 years, and 100 years, and a billion years, and so on. So it's an unbelievable, unimaginable ferment of progress by our standards. I mean, it'll seem normal then. They'll be complaining just as we do now, because there's an infinite amount of improvement still to be done even then. So as Popper says, we may all know little bits of knowledge that are different from each other, but in our infinite ignorance we are all alike. And so this infinite ignorance will still be there a billion years from now.
Yeah, as I think you've said before, knowledge-laden information is more resilient than any other physical object.
Yes, of course. So the 2 + 2 is 4 will still be true, although maybe they will have a better language for it, a better understanding of it. I was speaking of 2 and 2 and 4 earlier, but there's also plus and equals, which are deep concepts that equals hasn't existed very long, that concept, a few centuries. Plus has, because people were adding goats to a field with a certain number of goats, and they were tallying, they were keeping track of whether they'd retrieved all their goats by making the number of marks equal to the number of goats. And for them too, 4 was definitely equal to 3 + 1.
Yeah. There's a lot of powerful people right now lobbying to regulate AI and to regulate the free exercise of mathematics. Why do you think they're wrong?
Well, this is an old story, and the reason that they were wrong 100 years ago and 1,000 years ago is the same reason that they're wrong now. They look at problems and they think they're insoluble because they haven't been solved, and therefore they want to prevent the progress that is going to cause the problems. Now, generically, what that will do is it will make the progress happen in the wrong place. It will happen among people who do not obey the regulation. And those people are people who are alienated from the best culture, and they will then become a danger to the best culture. Now, I'm speaking in general terms about progress in computing and so on, but I think this particular thing you've mentioned is actually not going to be that much of a danger. AGI will, artificial general intelligence, will present a whole load of new problems which will have to be solved, no doubt with the help of AGI. But AI, the kind of thing we have now with ChatGPT and that kind of thing, which is amazingly and increasingly useful and is going to have unpredictable effects on society, most of them good, isn't anything profound. It's no different from having a calculator or a slide rule. Both the calculator and the slide rule did change a lot. and it changed society as well. The word computer, only 100 years ago, the word computer referred to people. It referred to clerks sitting in arrays of desks and checking arithmetic calculations. And it was error prone, so they had error correcting mechanisms. Now that's done, now a computer means something else, and there are no computers who are people. Similarly, AI, looking things up, collating knowledge from different places and gathering them together into a summary, that is a task that until, well, I suppose it began to improve with search engines, but not the collating part. So the collating and relating different pieces of information that you've trawled from existing knowledge, that has only been accessible for a couple of years, and it's extremely useful. I use it every day. But this is a different kind of thing from a general intelligence such as a human is. I don't think we're anywhere near making a general intelligence artificially. And the AI functionalities that exist today are not steps on the way to making AGI. They're, if anything, they are steps in the opposite direction, because they are steps in the direction of making a predictable functionality, a functionality that we know will retrieve the right piece of information from the news and not give us fake news, that it will express it in terms that aren't racist or sexist or any other ists that currently our fads say it shouldn't have. So we know that a better AI is something that meets the criteria more narrowly. This is the very thing that prevented human progress for hundreds of thousands of years. We want to make a computer, to make AGI, we need to make a computer program that does the opposite of that, that is unpredictable. That when it's creative, that's by definition, its function, its output has not been predicted. If it had been predicted, we wouldn't need to program an AGI to create it. So we don't know how to do that, and present techniques are doing the opposite. Now the opposite is pretty useful. I don't know exactly how useful or how much it will revolutionize the world, but it's certainly very useful to me. But AGI, I see, unfortunately, no hint of AGI even on the horizon.
You take issue with the we're all running out of resources stance. Can you expand on that?
Yeah, so the standard response to that mistake is to point out that nothing's a resource until someone creates the idea of how to use it. So I spoke earlier about England being a death trap before humans came here. A bit later, at the Industrial Revolution, people spoke of England as an island of iron ore and coal. So it's full of iron ore and coal, and so people would be saying, people did say at the time, that we're really lucky that we were sitting on an island of iron ore and coal, which were resources that we could use. But those resources were not there until people created the idea of how to use them. And there's a nice bit of history, if I can remember the historian's name, Howes, is it Anton Howes, who is a historian of technology, and he has recently done some work which shows that the upswing in GNP and general welfare in England happened before what we normally call the Industrial Revolution, and it was fueled not by coal and railways and factories. It was fueled by canals. So canals were being made like 100 years before the time when we normally think the Industrial Revolution happened, and they were creating prosperity at that time, even before all the things that we now associate. Now, canals were being made in antiquity. They're not a new idea, but the idea for how to use canals to make prosperity, that was a new idea, which people had and got rich off, and so on. This is now, with benefit of hindsight, I think I remember that the TV documentary series with Mark Williams called Industrial Revelations. The TV series Industrial Revelations goes through the history of this, and it starts with I think something like showing some sheep in a field, and you know, this was the wealth of England before all this happened. The Lord Chancellor in the House of Lords sits on the wool sack. The wool sack is a sack of wool. Actually, recently they renovated it and they found it was full of horsehair, not wool. So at some point, but traditionally it was full of wool, and that was to remind the lords what the wealth of England rested on, and they better not do anything to impair the production of wool. So England used to export wool to the Netherlands, and they used to make clothes out of it, and so on. And so then Mark Williams says, okay, so that went on for hundreds of years, and then somebody realized, I forget what it was that they realized, but they realized that if they could somehow get the wool to Manchester or Liverpool cheaply, then they'd earn a lot more money, and they'd create a lot more wealth. And so how do you do that? The roads were terrible, and you know, if you dragged the wool a couple of 100 miles, that would cost more than the increase in utility. And so they started making canals, and only then did they start. Only like another century later did they start making railways. So the water used to make the canals was a resource. It was a resource for hundreds of thousands of years, and no one used it. The iron to make shovels with which they excavated the canals was known since the end of the Bronze Age in about 1000 BC. So they could make shovels, they could have made canals. They did make some canals, but they didn't have the idea, they didn't have the ideas necessary to make a growing economy. And those ideas came together, and people like Anton Howes are dissecting the details of how it happened, which amazingly are not very well known. Possibly because of what you said earlier, possibly because there has been a fad for denigrating that very process, for saying that it wasn't good, it was bad, and we shouldn't celebrate it, we should regret it. So they don't know that they're advocating going back to living off sheep with a hundredth of the people that we have now. But it's a fad to say that, but not really to do it.
In one of our previous conversations, you said you were reading some work from Popper, and that was when you realized that if this epistemology that you were reading were true, then everything in existing educational theory was false.
Yes, I remember where I was sitting at the time, and I was thinking, oh my God. Because I hadn't thought of educational theory before. I was reading Popper for a completely unrelated reason. Well, you know, everything's related, but I didn't know it was related.
What made you question it?
Well, I was simply taking seriously what he was saying about knowledge. Now, one of the things about Popper's philosophical writing is that he says that he is not a system builder. So he doesn't point out, he very rarely points out how one of his ideas about a thing like progress in science relates to another thing like why Plato was wrong about philosopher kings. It's implicit. It's all the same idea, but he doesn't hammer away as he should. And so I only realized this very gradually. But by that time, I can't remember it that clearly, but I think I was on the lookout for connections between different ideas of Popper's and also between Popper's ideas and other things. So when Popper said there is no such thing as instruction from without, there is only a conjecture from within, he was actually talking about biology. But you know, anyone who knows that there's another meaning to the word instruction will be thinking of education in that context. At least I did. So then I don't know if it was that passage or some other passage that I was reading that made me think, well, basically, I can't remember the terminology I would use, but in terminology that I would use now, I would say that the whole of existing education theory and practice is saturated with the bucket theory of knowledge, or the bucket theory of the mind. And in some cases that doesn't matter. You know, we learn. You know, I need to know about quantum statistical mechanics or something, so I pick up a book about it. And the metaphor is that I pick up the book and I pour it into me. And the fact that I'm really learning it by conjecturing all the time and using the book to hone my conjectures, to criticize my conjectures. And I engage in criticism of the book as well. That's not that important in that situation. But if you apply it to the situation of undergraduates learning the same thing, then if you think of that via the bucket theory, then what you want to happen is that all of them get the same knowledge. You know, you're pouring the same knowledge into all of them, and then at the end they all get their certificates, which certifies that they are all the same as each other. And as if what we want of physicists is that they all be the same. That is ridiculous. And if I say it out loud in that way, everyone knows it's ridiculous. But because of the educational traditions and memes and educational practice that everyone is familiar with, people just don't notice this. People just sweep away the cognitive dissonance or whatever. So that will make for university courses which sabotage the very learning that we want the undergraduates to do if they are to be physicists. Now, you know, some of them are learning physics because they are doing something else, like engineering. Perhaps they don't care about physics. They just want few things to remember because the place they want to be creative is in designing a new kind of bridge or whatever. That's all right, but so long as that's a subsidiary part of what they're doing, and if they're doing it voluntarily for their purpose, which will always be different from each other, because one of them's doing engineering and another one is doing sewage farms and, you know, whatever. Perhaps that's a bad example, but. So, and then when it comes to education of children, then it's a complete disaster. because it's just assuming something that isn't true, and not only about the way that children learn, which is again only by conjecture and criticism, but it's also misconstruing what children are. So people think that you have to be prepared for life. So you have to be standardized so that you can later become diverse. You have to have your creativity thwarted so that later you can be creative, because you need a certain basis. Obviously everyone needs to learn to read, and yeah, that's very misleading, because it's not obvious that everyone needs to learn to read at the same age, to the same proficiency, of the same kind of material. And the same for writing, you know. Relatively recently, people started to type more than they write. Yet, teaching children to type has not caught up. It never catches up, because at best, people are thinking of education as the thing that they would have wanted to know. I mean, that's at best, because usually they don't even think that. But that means that every improvement that the pupils make, when they say, you know, why should we learn to write? Oh, well, because, you know, you won't get a job, and it's not true. Being able to write is no longer a requirement for any job, or maybe 1 in a million, and so on. Whereas as recently as when I was a child, it was 999,000 out of a million. So in practice, by not recognizing that disobedience, or rather that, I was going to say disobedience is creativity, and in a way it is, but it might be bad creativity. But creativity is disobedience. By not recognizing that, by suppressing disobedience, you're suppressing creativity always. Apart from, you know, mass murderers or something. But even then, it's only the actions that have to, of criminals, that have to be suppressed. Their ideas are best dealt with in non-violent ways. So we need to make a physically safe society, but not a society safe from ideas, unless they're ideas about violence or intolerance or suppressing the growth of knowledge. And there are many such ideas around. But the people you mentioned that want to regulate improvements in computer programming, I definitely wouldn't recommend imprisoning them. I would recommend persuading them, and maybe we can do that.
You've said before that protecting the means of improving our knowledge is more important than any particular piece of knowledge. Yeah. But that also is a kind of knowledge, right? Knowledge about knowledge.
Yes, and then we need to protect the means of improving that. Fortunately, it's not a hierarchy. Knowledge doesn't come in a hierarchy with the knowledge about knowledge about knowledge at the top of the hierarchy, because that would mean you could never change that, which would mean that you can never improve that, which would mean that it never improved, which eventually would mean that nothing else improved. Fortunately, criticism can come from anywhere. It's not true that you need to attain a certain level of competence in physics in order to be able to criticize an idea at the forefront of physics. It's true that most of your ideas criticizing it will stem from the fact that you didn't get it. But even then, the way you didn't get it will be different from everyone else's. And it might, when I'm asked a question about physics that I've never, and it has a misconception that I've never heard before, creating the answer to that helps not only the person who asked the question, but it helps me, because I get an angle on existing knowledge that I hadn't had before. And looking at existing knowledge from a different angle is often the way to make progress. When you're trying to find your way through the forest, and you're lost, and if you can climb up on a hill or up a tree or something or other, so you can see the vista, then changing your vista, changing how you see the problem that faces you, can be the key to solving the problem. I mean, it's not infallible, nothing's infallible, but one should be open to different ideas and different modes of criticism and different criticisms. When I see education theory being pontificated about on X, it's often remarkable how they hit perfectly the bullseye of the wrong thing. They will say something that really succinctly expresses the bucket theory and how more obedience is needed. Just currently, there's a thing about mobile phones being forbidden in schools, and it would be hilarious if it weren't so tragic. 100 years ago it was novels, and then 50 years ago it was comics, and all these things. Now these things are compulsory. When I was in school, calculators, handheld calculators, were just coming in, and we weren't allowed them. And I visited the school for rather a strange reason with an old school friend of mine who had been in the same class, and I saw that in the classrooms, at the back of the class, every classroom had a calculator. So it had gone from being forbidden to being compulsory in much less than a generation. And then on the same visit, I saw a sheet of physics marked something like 2 out of 10, and then a disparaging remark. And I found that terribly tragic. I was stunned, because it's as if somebody was taking black paint and painting over the Mona Lisa. There's something so wonderful that ostensibly being learnt here, and it results in someone being what's the right word? Punished, basically. Someone being punished for having a different view, for not getting it. So not getting it is the key to progress. So what he was taught was either that physics wasn't for him, and he would go off and do something else, or he learned how to say the right thing that would get the 10 out of 10, or the 8 out of 10, or whatever. I mean, why are there exams in which the students don't get 10 out of 10? I mean, what is the point of... Well, I know what the point is. The point is that only then can you have a system of coercion, where you're forced to get nearer the desired output, and punished as long as you don't. So in another universe, that teacher couldn't think of a suitable nasty remark, and instead put a helpful remark or something, or no remark would have been best probably. And that person went on to solve a deep problem in physics.
Like imagine if Mozart was forced to write math equations as a child, right? Instead of...
Well, he was forced to write music, so yeah,
Okay.
yeah. He's the exception that, to this rule. I mean, lots of children were trained in those days. If they had parents who were in the music society, they were trained to perform. They were sort of performing monkeys kind of thing, and Mozart was one of those. He was also taught to compose. His music is generally, you know, I'm not an expert in music. His music until the age of 16 is generally considered not to be very good, and it's not great until he was in his 20s. On the other hand, Mendelssohn was not as great as Mozart, but he was composing epoch-making music before the age of 16. And his name was Felix, which means happy. So I kind of hope that he was happy, and that's what made him achieve greatness. And Mozart was Amadeus, which means loving God or beloved of God, which didn't help him at all. But somehow he made it. But most of his contemporaries didn't.
But you think progress in physics has slowed down a bit recently? Is it, do you believe in the low-hanging fruit theory?
Yeah, so I don't believe, I think there's more low-hanging fruit now than there ever was in the history of science. I think there has been a slowdown, and I spoke to Feynman, great highlight of my life. I only spoke to him once for a few hours, and we had a wide-ranging conversation, mostly about quantum theory and computation. But we deviated a bit to talk about physics generally. And I said, you know, seems to have slowed down, and he said, there will be no more great physicists. And I was like, oh, you know, what makes you say that? You know, because I wasn't thinking like that at all. Because I was lucky enough to be among several of them and learning from them. And he said there will be no more of them. And so I said, why? And he said, well, because of physics education. And he didn't put it in exactly the way that I would today. But it was very narrow, and everybody was taught to do the same thing. I don't think he had any objection to this concept of being taught a thing, or to have a curriculum, but he thought it was becoming narrower and narrower. And the reason it's becoming narrower is because that's the only way you can base it on exams. And if you want to have a world in which most people go to university, let's say, then you need to have standards for going to university. And these standards have to be determined by exams, otherwise it's unfair. And if they're determined by exams, they have to be determined by a uniform curriculum, so across the whole country. Again, well, when I was in school, there was no national curriculum. Every school had its own curriculum. There were dozens of different examination boards that set exams, and each school could choose, you know, we'll have this board for physics and we'll have this board for history, and, you know, according to what the teachers in the school thought was a good idea to force their pupils to learn. Okay, so that part of it wasn't the way I would have it, but the state didn't take a view, and most importantly, it didn't take it didn't take a uniform view that everybody in the country had to learn this thing. And that was the thing that Feynman was objecting to, that everybody in the country learning the same thing, and by the time they get to university, and by the time they've done an undergraduate degree, they've learned to become proficient. I mean, those that pass through the sieve and eventually get to become physicists or something, they have all learned how to do the same thing in the same way. And that's going to put a damper on doing things a different way, a new way. Of course, Feynman, in his life, was in his life and in his research career, he was constantly doing things in a new way, in ways that people didn't approve of. I think, well, I'm not a pessimist, so I don't think there aren't going to be any more great physicists. I'm expecting that there are, because I'm expecting that the Enlightenment will spread to educational theory, as it has spread to many other aspects of life. At the moment, we're in a bit of a stasis, in some ways going backwards, in some ways still going forwards. But that's nothing compared with stases, if that's the right plural, that have existed in history. And even when there was revolution in rapidly increasing knowledge, like in the 19th century, this was done by a very small number of people. So there is a way of making everybody in the country, everybody in the world, into this Renaissance man or aristocratic scientist who aspires to improve things and you know, spends his own money buying the new kind of instrument and then writes a letter to the Royal Society about what he's done. That kind of thing could be how everyone is. I mean, those, just as the people 300,000 years ago had the same brains and the same capacity for creativity as we do, so the aristocrats were no different, despite what they might have thought about having blue blood. They were no different from the peasants. It's just that their culture allowed some of them to be creative and to want to open up new vistas in knowledge. Darwin wanted to go on a ship, which was a horrible experience at the time, and go and study finches in the Galapagos or wherever it was. And ironically, I think he could have arrived at the same theory just from his armchair. Darwinism is really a philosophical theory. There's hardly any science in it. But the way he thought about it was via being a naturalist. And so seeing the finches with their different beaks.
Was that, yeah, the empiricist argument? Do you think he fell into that trap? Although, like, a lot of people are Popperians, right? Like, because that's the only way to create knowledge.
Everyone is in fact a Popperian in every area in which they are creative, but they may not know they are. So if you ask them, what is it that you do in order to get your great results? Many of them will still say to this day, well, I look at the experiments and I try to extract from the experiments the law that governs the outcomes of these experiments. And Newton said that. And it's not true. So he was great at physics, he was great at mathematics, but he was not great at the philosophy of knowledge. His philosophy of knowledge was really the same as what Plato had a couple of thousand years before. And Popper's idea, you know, sometimes I hear people talking about their own path, creative path, and I hear them saying Popperian things. I just heard John Cleese the other day talking about, I mean, I'm sure he's never heard of Popper, but he has learned correctly, unlike Newton. He has learned what it takes to become a great writer of comedy. And he's, you know, one of the greatest ever writers of comedy, and he understood a lot about, and it's very impressive. And if that could be bottled and spread to the country, then everything would take a massive leap forward, like the Enlightenment, but with everybody doing it instead of just a tiny minority.
In the beginning of Infinity, you mentioned that the word sustainable has two kinds of opposite meanings, and in the long run, only progress is sustainable.
Yes.
Can you expand on that, will you?
Yes, so many, because of the entrenched misconceptions about knowledge, many words that are in a general area of knowledge and progress and new knowledge, and many words have dual meanings. One good and one bad, or I would say one good and one evil. So the problem, for example, that one sense of problem is what the Apollo 13 astronauts said when they radioed down, Houston, we have a problem. That means something really bad, it might kill us. Although once even that, when that got down to Houston and the team of 1,000 people started working on that problem, for them that was good. They were in their element. They were solving problems. This is what God put them on Earth to do, and they did it, and they did it in time, and so on. But for the astronauts, it was not good. It was bad. But a problem can also be what Popper says in his autobiography. He says that the meaning of life, or the best thing in life, or something.
All life is problem solving.
All life is problem solving, but he said that the best thing is to find a problem, fall in love with it, and then live with that problem for the rest of your life. He doesn't say anything about solving it. Live with that problem, and if by chance you should solve it, that's kind of, oh dear, you know, what's going to happen? Then the chances are that there will be many enchanting problem children coming out of that solution. So that's you know, the best possible interpretation of the concept problem, the word problem. So it means two incredibly distantly opposite things. Now, what was the word you asked me about?
Sustainable.
Sustainable, yeah. So sustainable can either mean giving someone what they need. So, you know, a graduate student needs a certain stipend to do research, to sustain their research. That's one meaning. But sustainable also means forcing things to remain the same. So it means finding a way of generating electricity or whatever it is that can be made to go on forever. There is no such thing, but there is a misconception that not only is there such a thing, but that is the ultimate good. That is the moral, those are the moral coordinates by which things are judged now, social things are judged today. So again, those are opposite senses of the word sustainable. One is giving you what you need, the other is preventing you from getting what you need. Now, as you mentioned, there is no sustainable in the sense of something that can be used forever, and something which, if you're prevented from changing it, will not cause disaster eventually. Our problem situation is constantly changing. If nothing else, the sun and the asteroids and so on will keep producing problems. The atmosphere produces problems, and there is no sustainable state, because any state of that is going to be changed by forces not under our control. And the only thing we can do is to improve our capacity for solving problems. And so that quote, I think it's from me, something about that the only sustainable thing is progress. Because progress is the thing that's needed to prevent disaster, and new forms of disaster will always happen. I say in the book, in the beginning of Infinity, that in 1900, radioactivity hadn't been discovered. So if they had thought about how will we get energy in the distant, you know, where would our energy come from in the year 2000, they wouldn't have been able to say nuclear power stations. They would have had to think of something that isn't sustainable. Only they didn't, because they didn't think like that. They thought in terms of progress in those days. But if they had, not only could they not have predicted that, they couldn't have predicted that in the 1960s, when people did have nuclear power, they decided not to, for reasons that would have been completely incomprehensible to people in 1900. And I hope will be incomprehensible to people very soon now.
Because the growth of knowledge is unpredictable.
Yes.
Yeah. I know it's hard to put a number to it, but how optimistic are you for the near future, and maybe what do you see as the biggest threats to Western civilization right now?
So I don't think so. The cause of the fads and shibboleths and taboos that we were talking about, you know, the thing that stopped nuclear power and so on, I don't think they are capable of bringing down civilization. They're only capable of slowing down civilization, which is risky for the usual reasons, but I can't really imagine that we're going to die of woke. If anything worries me about the present state, you know, what the state of civilization being in danger, it's technology in the hands of the enemies of civilization. So nuclear weapons, artificial pandemics, not AI, but AGI.
But AI in the hands of the bad people, and if everyone is, so if you regulate AI and say, oh, let the good guys handle it.
Yeah, that's a slightly different kind of problem, but yes, but I don't think even that can bring down civilization. But AGI in the hands of the wrong people could, especially if the people who are trying to carry forward our civilization are forcibly prevented. It's actually quite amusing, because they kind of assume, because they're assuming that AGI will be invented by the same method that current AI is invented, they're thinking of AGI as being something that will involve huge computers, banks, and I think that it's my guess. I don't know when it will be invented or how, but my guess is that it will be a qualitative improvement in how to make artificial knowledge creation. And Turing thought it could be done in 2 megabytes. Now, I wouldn't be at all surprised if it can be done in 2 gigabytes, like on my computer. Now, if I invent it, if I end up inventing it, I will have invented it on my computer in my house, and none of the regulations will know about it until I announce it. And of course, I wouldn't be telling you now if I had. So, you know, you'll have to guess whether I have actually done this, but I can tell you that if I do it, I won't announce it.
I think that's a good place to end. Thank you so much, David.
It was fun.